Good afternoon, everybody. Thank you for coming. Thank you to Craft for inviting me. Despite the fact that I am European, I have never made it to Hungary before, so it was wonderful to get here to Budapest and to see it in the lovely weather yesterday. So this is a talk on continuous experimentation. Just before I get into that, what it is, I'll turn on my clicker. There are a lot of resources for this talk at this link. If you want to take pictures of my slides and tweet them, please feel free. But if you just want to grab a link afterwards that has all of my slides and a bunch of footnotes and links, then you can get it from this URL. That's also, I just posted that on my Twitter, and I'll put this link up at the end as well. Okay, so continuous experimentation, eh? So I've been in industry 20 years. So I got my first job outside of college 20 years ago. And for almost all of that, I've been using agile techniques. So I came across Kent Beck's white book in 2000. And so I've been using agile for a long time. And despite some of the bad rep it gets occasionally in our industry, I still think that the core of the agile values are really what I think is useful for delivering software. I'm also a big proponent of DevOps. So I work with Dan North and Jez Humble, who gave a really interesting talk earlier on the birth of DevOps. I worked with them back in the mid-2000s. And I was even a sysadmin in my first job. So even though I mostly do application development, there's always been this part of me that's been interested in operations. And then over the last 4 years, I've really got into this whole idea of serverless. And I'll talk a little bit about serverless later on in the talk. But the reason I'm interested in serverless goes in with this whole DevOps and agile thing. And when you combine all these three areas, a whole bunch of interesting opportunities become available. And over the last 20 years, what we've really seen is that the lead time for delivering software has decreased from years to weeks. And now we even see an opportunity to reduce this further to days or even hours. And I think that not only does this speed things up, but it really has the opportunity to transform how we produce software to one of experimentation, continuous experimentation. All well and good, you may say, but what's the point? What are the advantages that that brings? And what are the challenges that we may face as we do so? And how do we surmount those challenges? Well, these are all the questions that I want to approach in this talk this afternoon. But before I do any of that, let's get philosophical for a moment. What is the point of software engineering? It's not a question we think of too often because we're too wrapped up in our day-to-day work, and that's fine. You know, we have important things to be doing. But there has to be a reason why we're doing it in the first place. One reason is to enable our customer or our users to be more awesome. To be able to do something that they couldn't do before, or let them do something that they've already been doing before, but far more efficiently, at a higher quality, or at less cost. So I borrowed this question from my good friend Daniel North, and his answer to this is the goal of software is to sustainably minimize lead time to business impact. And the point is that we're not here just to produce software. We're not in the deliverables business. We're interested in the outcomes of our software, the delight of our users, and what they can do with the software that we create. It's great. But why is lead time, reducing lead time, so important in this? Well, for two reasons. First of all, it gets this useful software in the hands of our users faster. And as a nice side effect of that, it tends to unlock revenue faster. The second benefit of minimizing lead time is it lets us try more ideas. And why is that important? Well, I'll explore that in a little while. But first of all, let's go on a little history lesson. And I want to take you on a journey from where we used to be as an industry to where we are today. So who here has been in the industry for more than 15 years? Some of you. A few of you. Smattering. Okay. So for those of you that weren't, which is the majority, I'm going to tell you a little about what things were like back in those good old days, when it used to take anywhere from 6 months to 2 years typically to deliver software. 6 months to 2 years. Why on earth did it take so long? Well, there were good reasons. We weren't all just, slow. There were reasons for this. First of all, releasing software was very expensive. And it was expensive because change management was expensive, because testing was expensive, and a whole bunch of other reasons. And because of those reasons, we optimized our process for large groups of people working on one product area with a small number of releases. Second reason everything was so slow, infrastructure was really expensive. Infrastructure and the labor to manage it was very expensive, and so we optimized our architecture to reduce the total number of components that we deployed. And we often used multi-tenancy of various configurations and various customers to bring all of those customers and configurations into one runtime. And not only was infrastructure expensive, but changing infrastructure was expensive. This is a separate point. And we needed to use the same infrastructure over months or years for it to be cost effective. And this is why traditionally our production systems have been mutable, have been changeable, with all the complexities that that brings. So all of these constraints drove us to a project mentality in how we worked on industrial software teams. We needed significant coordination across large groups of people, and we used processes like waterfall and tools like Gantt charts in order to help us be efficient in that world. But over the years, the constraints of software delivery have fundamentally changed. Releasing software is not nearly as expensive as it was because groups of practices that we have now under the umbrella of continuous delivery have come along, which have reduced the cost of testing and reduced change management costs, etc. Infrastructure is not nearly as expensive as it was, and the cost of change of infrastructure is almost trivial nowadays, all because of the shift to hosting in the cloud. Which means that we are now able to release software much more quickly. Continuous deployment of several releases per day is now commonplace. So here's a quote. This quote's actually from 3 years ago, so it's not even that new, from a guy called Sri Kote, who used to be the CTO of Comcast. And for those of you who don't know, Comcast is a very large cable provider, cable TV provider and ISP in the United States. So a very traditional industrial company. He said this: "We used to ship our product every 12 to 18 months. In a 3 to 5 year period, we shipped 3 or 4 releases. Now we ship 3 releases every week." So A, that proves the point. About 15 years ago, everything was horrible. And B, it proves that massive, huge industrial companies can change significantly and increase their frequency of release by 2 orders of magnitude, which is quite extraordinary when you think about it. Now, tied in with this is the fact that lead time has also decreased. Remember, I mentioned that phrase earlier. And now we often talk of lead time for new features or new products in days or weeks rather than months or years. And this is a huge, huge change. And these reductions in cycle and lead times have changed how we approach software delivery as a process. And instead of focusing on projects and deliverables, we can now spend much more time thinking about the product that we're trying to build in the first place. Or, in other words, instead of focusing on how many little things we can build, our outputs, we can instead optimize for the effectiveness of our software in the hands of our customer, the outcome that it has, which is far more important. Now, a lead time of days and weeks is a vast improvement over the months and years that we saw 15 years ago. But we can do even better than that. So here's a quote from Adrian Cockcroft. Adrian just spoke in the previous session on a different stage. Adrian said this a couple of years ago. "We're starting to see applications be built in ridiculously short time periods." And when he says ridiculously short, he's talking about hours. And he wasn't joking. He actually saw this with customers. And think about that. Building an entirely new product in hours. That's really quite amazing. Quite a change in 15 years. Now, reducing our lead time further and further allows us to focus on 2 ugly truths of software. Ugly truth number 1, we don't know up front what the best solution is. When we're building software, what we're making isn't something that we've made before, otherwise why would we be doing it? Building software products is a complex problem. And so knowing up front what the best solution is just straight up hard. Even the best minds in the world are going to find it hard. It's actually truth number one. The thing is, when we start working on a feature or a product, we have an idea of what it is that we're trying to implement. But there's another problem. Most of our ideas suck. It's true. Even though when we're working on solving a particular idea, they feel great, history tells us that we're wrong. History tells us that most of our ideas suck. That's not our fault. That's just, that's just who we are. Jeff Patton says this, and Jeff Patton's really smart. I recommend checking out Jeff Patton. He's this wonderful writer and speaker about product management. But here's the thing. If we have an environment where we can deliver an idea from scratch in just a few hours, then we can try out many, many more ideas than we used to. And not all of our ideas suck, just most of them. In other words, we can play a numbers game. And this way, we're far more likely to come across a winner, the one that is going to make our customer awesome. So enterprises can now start embracing lean management and experimentation as their main ways of working. Startups have been using this thinking for years, using ideas from Lean Startup and elsewhere. Lean Startup has been around, 10 years now? Fantastic book if you've never read it. So enterprises can now themselves start building minimum viable products, assess success, and keep pivoting on their ideas until they find something that works really well. And enterprises can think about this because the fact that shorter lead times in enterprise development is now a real thing. So we need to stop thinking of our software organizations as feature factories. This mindset of the never-ending backlog is a remnant of working in a project-based, output-oriented environment. And that's an environment that's optimized for a few releases. And that system is just out of date. Instead, we can transform our organizations into product laboratories, embracing a model of continuous experimentation. And this allows us to build products that truly do make our customers awesome. Now, such a significant rethinking of how we approach software engineering doesn't come without challenges. How do we get to this point of continuous experimentation? Well, I want to take a look at some of these challenges and then across technical and organizational spectrums. So some technical challenges. First of all, we want to minimize incidental complexity. We want to maximize instead the amount of time that we spend addressing the core of an actual customer problem. But we need to do this and still have valid, safe production deployment at scale. Next up, we want to reduce infrastructure cost and infrastructure cost commitment for deploying a new system. An experiment might only last a couple of days, and so we don't want to lock ourselves into an expensive system. And we also want to reduce technological overhead from having many different experiments. We're going to have lots of small systems, and how do we have sufficient decoupling? Now let's sort of shift gears a little into a more organizational and cultural area. We want to minimize the time it takes to go from our code being ready to it being deployed for the very first time. Now, there are some technical challenges here, but there are also a bunch of process and organizational concerns that we have to think about. We have to change the culture of our organizations to encourage continuous learning. We're not going to be doing the same thing repetitively in a feature factory anymore, after all. And finally, product innovation needs to be spread around teams and not just be the responsibility of product managers. And so that we can source a whole bunch of ideas from all of our people and that we can move those ideas forward at a rapid pace. This is going to be a much less structured world, and so we need to think about how we approach safety. And so there are a bunch of safety challenges that we should also think about. First, we need to enable a psychologically safe environment for our experiments to fail. We need to maintain budgetary safety in a significantly more dynamic environment. And we also need to maintain appropriate security and data access safety. Now, these 9 challenges are not the only ones at all that exist in this world, but they're enough to get us thinking about the type of changes that we're going to have to grapple with. And I'm going to spend the rest of this time talking about how we might solve some of these 9 challenges. And the good news is that we already have most of the tools that we need to get through all these. So first of all, let's talk about some of those technical challenges. Now, I think that serverless is a key technique to resolving many of the technology challenges that we're going to face in this whole brave new world. I've been using serverless now for about 4 years, serverless systems for about 4 years. 3 years ago, I wrote this article on serverless architectures that Martin Fowler was kind enough to host on his website. And since then, I've started my own consulting business with my business partner, John Chapin. And we help people use the cloud and use serverless as part of that more effectively within their companies. So, quick serverless reminder for some of you, or a quick introduction to serverless for the rest of you. Serverless architectures are ones that make significant use of serverless services. There are plenty of serverless services in the world now. So on the left-hand side, we've got Amazon Lambda. This is an example of a functions as a service platform. On the right-hand side, we have some fundamental infrastructure services, again from Amazon. I spend most of my time in Amazon, but Microsoft and Google have the equivalents of most of these. So on the right-hand side, we have fundamental infrastructure, but these are actually serverless fundamental infrastructure. And in the middle, we have services that are sort of a little more application-oriented. So on the bottom there, we have Auth0. And Auth0 are a company that produce a service that does user management and password management for you so that you never have to play the story in iteration 0 of implement login, because Auth0 have already implemented login for you. And Google Firebase is a great sort of application-level database produced by Google. So these are all serverless services, and they are components of a serverless architecture. But they're quite different. We've got, block storage on the right and a compute platform on the left. Why do all these things come together under the serverless umbrella? That's because they all satisfy a number of common attributes. And I'm going to talk about some of the most important attributes for this continuous experimentation world. First of all, none of these services require, on our part as users, any management of server hosts or server processes. We're not thinking of any long-lived entities when we're using these services. Obviously, the vendor has to be thinking about the server hosts and the server processes, but we don't have to. Next up, all of these things self-auto-provision and auto-scale based upon load. We don't need to do any resource planning or any resource management. We just don't need to know how big our thing's going to be. That's on the part of the vendor to figure all of that out. And finally, for now anyway, they also have costs that are based upon actual precise usage that we pay for afterwards. We don't have to pay up front. We don't have to plan up front how much these things are going to cost. We'll be charged according to how much we use and no more. And so there are some other attributes, but I'm not going to get into them today. So how do these attributes help us in these technology challenges of continuous experimentation? So first of all, many serverless services offer pre-built logic that we can incorporate as a service, things like that Auth0 that I just mentioned. Serverless is not just about Lambda and Azure functions and Google Cloud functions. A lot of it is about these application-level services that mean we don't have to write any code in the first place. And so exploring what these serverless application-level services are mean that we may not need to build any generic logic in the first place. Alternatively, when we do need to write some code, we have a very lightweight model for running that code in functions as a service. And that's things like Amazon Lambda and Google Cloud Functions and Azure Functions and a number of other platforms as well. Serverless handles almost all of the systems administration that we care about, and I'm using systems administration as a phrase there and not operations. Operations is a lot bigger bucket. We have to still think about ops, but we don't really need to think about sysadmin when we're using serverless services, whether those are general compute services or data storage or networking or any of that kind of thing. And finally, serverless scales out horizontally without any significant effort on our parts. We don't have to set up scaling alarms or anything like that That's on the part of the vendor to figure out how these things will scale. And this is important because our experiments are not necessarily going to be valid unless we are able to test them out at scale. You know, it's not necessarily, we can't always test these things using 5 users. We might need to test out these experiments with 5 million users, and so we do need real scale quickly and easily. Okay, so that's technical challenge number 1. Let's look at our next challenge. How do we reduce our infrastructure cost and our commitment to infrastructure costs when we're deploying a brand new system? Well, first of all, serverless has very, very little overhead cost. Almost the entire costs when we use serverless are based upon the actual usage, the actual flow of data through a system. And those costs scale up from 0. Like if we're not using it, we don't pay for anything. So the costs just scale up as we use it. And even more importantly in this world of experimentation, those costs scale back down again as we're not using it. So if we suddenly turn off these 5 million users, that's fine. We're not going to be paying for the system anymore. It's not chewing up at our budget in the background without us thinking. And finally, in traditional systems, it makes sense from a cost optimization point of view to co-locate different features in one system or different features in one cluster if you're being hip and cool and using Kubernetes. And that brings complexity, because any new work that you're doing has to tie into that existing environment in order for you to gain the cost optimizations that come from sharing these features in one environment. That's just how we've been, that's just an idea that's so ingrained in our brains that it's even hard to think about that. But with serverless, that model is completely erased because costs just don't work that way. And this is a big deal, and it's one I don't think that even those of us that have been using serverless for 4 years have entirely grasped how fundamentally that changes how we build systems. This idea of there's no point optimizing multiple features into one thing to save costs. That just doesn't make any sense anymore in a serverless world. And so that's how we can reduce our infrastructure costs. So number 3, we need a technical platform that actively encourages decoupling of components in order to not go completely bonkers in this world. And that's what we get with the event-driven granular architecture that we get with serverless. It really does help us in that way. Sort of, you can build a monolith with Lambda, but it's really hard. And I've seen it done. But someone was asking me, oh, you can't build monoliths in Lambda. I was like, oh, you can. But it's really hard because it really tries to push you to a much more distributed way of thinking. Now, I'm not going to lie. I think serverless provides a really great foundation to solve this problem. But there's still a lot of work that needs to be done in the serverless community to really better document good architectures and patterns of how this stuff can look in a highly decomposed, long-lived, maintainable way. And I do want to mention one quick thing here. The cost savings of serverless are really useful and significant. And there's a lot of reasons that people get into serverless is because of the cost savings. But to me, that's not why I'm excited about serverless. It's not why I got really into serverless. It's not why I spent a long time writing that article. I'm interested in serverless because of the acceleration it brings to people using it. And if you're only using serverless for cost savings, I really do think that you're missing its main trick. And because it offers us the chance to bring about this change of mindset that I'm talking about today, I think that's by far the most important aspect for serverless. Now, a technical platform is not sufficient for continuous experimentation. We need to change our organizations as well. And we need an organizational platform or an organizational framework that's really going to complement this serverless platform that I was talking about before. So let's dig into the kind of organizational changes that we're going to need. So continuous experimentation is both about continuously delivering new tests, but also about making those tests provide ever more value to our users. So how do we change our organizations to make this happen? So the key lever as we start into these organizational concerns is DevOps. I love DevOps, but specifically we're talking about DevOps culture here. We're not talking necessarily about Puppet and Chef and automating our container deployments. We're talking about the culture changes that DevOps is all about. And this is really about bringing development and operations and other engineering activities all much, much, much closer together rather than having them performed in strictly siloed organizations. And a lot of the time, we're going to bring these activities onto one team, but even if we can't quite do that, then we're not going to have like strict work queues between all of these things. Now, if you want to learn more about this stuff, then I completely and utterly 100% recommend these two books, the DevOps Handbook and its sort of sibling book, Accelerate. Accelerate came out last year, written by Dr. Nicole Forsgren, Jez Humble, and Gene Kim. And these are going to both be amazing helps as you think about expanding your thinking into this world. Accelerate is especially great because it really takes all the ideas that most of us knew were right, sort of feeling-wise, and Nicole Forsgren is an absolute genius because she's taken all this incredible data and used it to prove through the wonder of statistics that these things are actually true. So DevOps has done a great job of improving our cycle time, and that allows our teams to practice continuous delivery and/or continuous deployment. And those techniques are definitely useful for us here, but we need more than that. We need to improve our zero to production lead time. This is not about cycles. This is going from zero to something brand new in production that didn't exist before. And much of that time, if we want to minimize it, is going to involve coding. So we're going to have very, very little time to launch our software. Maybe just an hour or two, or maybe just minutes. And so to perform this, we need automation to bring up these new systems and have a platform in serverless that can react to our requests easily. But more than that, we need a process and a culture that is going to support deploying brand new applications very quickly within hours. If you have an organizational process where any new system has to go through 2 to 4 weeks of change control before you can deploy it, then all of these benefits that we're talking about through the rest of this talk are completely and utterly useless. And so you need to transform your organization to one that can enable these things to be done before you can even think about some of the technical challenges. So that's the first one. We need to minimize initial deployment time. Now, there's no point in having continuous experimentation without also having continuous learning. A big point of each experiment or trial is feedback for figuring out what the next experiment should be. But oftentimes, that's not the way that we work. When we're engineers in feature factories, we take our requirements and then we crunch them up using the same process that we've ever done before, and then we get the next requirement and crunch them up. And then often times we're under time pressure, so we're furiously bashing at the keyboard. But that's it. Sort of, it's just like, you know, no learning, just crunch that code, right? But that's not going to work. We need an environment where we need to be constantly learning. And we, in fact, need to place learning as important as delivery. It's not a second part. It's as important as the delivery in the first place. And this learning is going to come in various forms. We need to learn about our customer because, again, the point of software is getting value to our customer. And if we're not learning about our customer, how are we ever going to figure out how to do that? We need to learn about our tools. Every new experiment might be something that's kind of a different shape, right? So we're going to need to understand what our tools can and can't do so that we can use the right tools at the right time and use our tools in effective ways. Here's the thing. We also need to learn about each other, right? A team is a team. It's made of a group of individuals, and not everybody is the same person. We're not actually a bunch of robots. We're a bunch of individuals who have strengths and weaknesses and passions and dislikes and all those things. And as a team, we need to learn about who the individuals on our team are and what they want to do and what they're strong at and what they're weak at so that we can be most effective when we're getting through these lots and lots and lots of quick experiments. As we do this, really the first thing we need to do is completely change our approach to management. I mean, no longer is it useful to build backlogs of work 3 months or 6 months or 9 months out and track that as a way of figuring out how effective we are. We instead need to continuously learn about what we're building and how effective those things are, and then adjust our plans based upon that. But it's not just on management. This is also on us as engineers. Who here went to Dan North's workshop yesterday? Anybody in the room? Okay, none of you. Dan did a workshop yesterday called Software Faster, and he's been giving this workshop now for a few years. So when we're in the process of writing code, what are we optimizing for? Writing the perfectly designed, highly efficient solution isn't necessarily the most appropriate thing to do when we're trying to learn about technology or a particular customer's need. And sometimes, this is me, the person who read the XP Whitebook 19 years ago, sometimes copying and pasting code is the best thing to do, assuming that we commit to going and tidying all that code up later if we actually find out it's going to be valuable in the long term. Now, Dan has been doing a lot of great work in this area about thinking about engineering team practices that are a little bit against the grain under this umbrella of software faster. And I highly encourage you to check out some of what he's done, and I provide some links to that in the resource document for this talk. Okay. So we also need to spread ownership of innovation. It's the whole team's responsibility now to think about what ownership is. I think product management has to become a mindset and not an individual. The most effective engineering teams are the ones that consider this idea of customer affinity and not just the best technical solution. Customer affinity is something that Martin Fowler wrote about on his website 12 years ago, and it's not something that is particularly common on teams. Now, not every individual on a team needs to wear every single hat. I'm not saying that. But I do think that we need to significantly break down the silos of roles that exist within software delivery, including the non-technical ones. We've done a pretty good job about breaking down the roles between QA and tester and ops person. I think we need to step outside the purely technical and break down some of the silos into the less technical ones. Now, I've seen a bunch of developers excel in this area of product thinking. And when we treat all of our engineers just as code robots, we're not untapping their full potential. So as we change product development from being a project process of regular cadence over time to one of continuous experimentation and feedback-based redirection, we need to drastically change how we approach risk and safety. Experiments are going to fail, product expectations are going to mutate, and the requirements of our technical environment may change drastically and quickly. Safe experimentation, as a phrase, is not a contradiction in terms. Science laboratories do this all the time. They have highly volatile chemicals that they're doing all kinds of wacky stuff with, but they are doing that in a safe way. We need to do the same thing in our product laboratories. We need to be actively embracing safety and thinking what are the equivalent of our big visors that we might put over our eyes. So I'm going to talk about safety here. First and most importantly, we need to allow our people to feel safe by creating an environment where failure is not something to be scared of. Jez talked a lot about this in a talk a couple of sessions ago. And Google figured this out years ago, and the New York Times wrote a great article about Google's own introspective studies. And here's this quote that is included. Google's data indicated that psychological safety, more than anything else, was critical to making a team work. Now, that might seem reasonable in the after, like, oh yeah, that seems fine, okay. But how much effort do we actually put into that in our own organizations? Here's another quote, which I'll get to in a second. Now, the best companies adopt failure as part of their process. And here's a quote from Jeff Bezos, the CEO of Amazon, right? Amazon not always known for having universally the best culture in the world, but I think there's a bunch of stuff they get really right. And Jeff Bezos said this a while ago about the Fire Phone. Who here remembers the Fire Phone? Not many of you precisely. It was a dismal failure. Massive failure because they spent a lot of money on it. Jeff Bezos said this about the failure of the Fire Phone. If you think that that was a big failure, we're working on much bigger failures right now, and I am not even kidding. Some of them are going to make the Fire Phone look like a tiny blip. The point here being that if we value experimentation, we have to actively embrace failure as part of learning and not just treat failure as a side effect. Failure has to be something that we consume, and it has to be part of who we are if we're really going to be experimenters. So how do we go about making our cultures ones in which it is safe to fail? Well, one idea is to think about using blameless postmortems. Jez and Nicole talk about this a lot in their books. Here's a quote from Bethany Macri of Etsy, who are really sort of one of the main proponents of blameless postmortems. She said this: "By removing blame, you remove fear. And by removing fear, you enable honesty. And honesty enables prevention. And prevention is all about how do we make a safer environment." I strongly recommend the Accelerate book on this. Even though you say, oh, it's DevOps, there's a ton of stuff in there about management and culture, especially around this area, and how it has been literally proven to make your companies more effective. So I strongly encourage you to take a look at Accelerate. Of course, it's not just enough to think about the safety of our individual coworkers. We need to think about the safety of the business as an organizational unit. And there are several areas here to be concerned about, but I want to talk about a couple. The first one is infrastructure budget. How do we make it safe to create entirely brand new stacks of infrastructure on a frequent basis, on a whim, up and down, all these massive stacks of infrastructure? How do we do that without bankrupting our companies? Because even though AWS is really good about helping us bring our costs down, trust me, it's also really easy to spend way more money on AWS than you were planning, when the difference between a $500 a month machine and a $20,000 a month machine is one character in a config file. You can bet it's easy to spend too much money on AWS. So how do we avoid bankrupting our companies when we might be making that mistake 100 times a day? So a couple of things. First of all, we need visibility and ownership of costs on our team. There's this great phrase in Accelerate about data safety and security, I'll get into a second, this phrase of shift left. We need to bring things that are normally downstream of what we do into the engineering team itself. And especially here, we need to bring the visibility of how much we're owning, how much we're costing, and the ownership of our costs onto the engineering team. And we also need to introduce automation and tooling so that teams can know how much that they've spent and be able to do something about it. Now, if you're on AWS, this has got a lot better in the last couple of years. So, for example, if you want to do this, one of the things I should recommend you do is you start using AWS sub-accounts liberally. Use short-lived sub-accounts, use T-mode sub-accounts, use ephemeral sub-accounts. Embrace sub-accounts. They're a great way of encapsulating cost. And the other thing that you can do if you use sub-accounts is that you can put quotas on sub-accounts so that you can much more quickly know when you've blown through the budget that you expected to spend. So this is new, and I strongly recommend this. And the final technical challenge, data and security safety. Now, we need to make security work as much a part of a team's responsibility as anything else. Again, we want to shift left our security onto our engineering team. We need to build shared tooling across the organization in a way that protects data but gives flexibility for experimentation. Where possible, we want to give teams the autonomy over their own access controls. Building review and exposing changes as part of their system of work, but allowing them to make these changes. And where necessary, we may still need cross-organizational change requests, but we need to optimize such things for flow and only really have them when team autonomy is insufficient. Now, I was led to the idea of putting the idea of safety to the fore. You know, it took a third of my challenges by Joshua Kerievsky. And he's been talking about this idea of safety for years and years and years. And his most recent way of talking about safety is through this idea of modern agile, which is a very simple set of values that embraces the heart of what I think is also most important about software development. Modern agile is entirely what you see on here. It's 14 words. You can read more about it at modernagile.org, but it's that. In fact, if you look at these things, experimenting and learn rapidly, delivering value continuously, making safety a prerequisite, and making people awesome, you'll see that that is spread throughout everything that I've just been talking about. So in this talk, I've shown that we now have the ability to have idea to production lead times of hours rather than years. And this enables us to think about how we approach product development in a very new way, one of continuous experimentation rather than the old project-oriented mindsets that we've used before. Continuous experimentation is a natural progression from continuous delivery, so it's not something entirely new. Serverless provides us with a technology platform to do this, but alone it's not sufficient to enable this change. Additionally, modern Agile provides us with a value framework, DevOps provides the principles and practices, And things like Dan North's software faster techniques and his patterns of effective teams give us ways of considering how we can change engineering itself, which really leaves one question. How will you transform your organization from a feature factory to a product laboratory? I hope I've given you some inspiration today and some ideas that you can take back to your own teams. Thank you very much. I'll be around for the rest of these 2 days, but I think we have some time for some Q&A.
Brilliant. Thank you, Mike, so much for this talk. I believe your talk perfectly complements Stefan's before yours.
Oh, great.
He was mostly about how not to be afraid of innovation, and you're about how to implement it in reality.
Awesome.
So thanks for the talk. It was amazing and inspiring. And let me give you the gift of the give you a gift on behalf of the craft organizers.
Thank you very much. Oh.
You're welcome. Everyone, you can hit up slido.com right now to upvote the questions that I'm going to ask Mike. And you can also write in your own questions. And after the talk, don't forget to rate this session. So let's look at the questions, Mike, okay? As service mesh developers are considered innovators, do you believe it's going to be more mainstream, quote unquote, in organizations' futures?
Interesting. So service meshes, in my experience, are mostly live in the world of containers, where you have container-based applications these days. And I think there's sort of, it's one of those areas of technology that are definitely ahead of the curve in serverless in some ways, but on the other hand are solving problems that you may not necessarily have when you're using a serverless world. So serverless is really more about using basically simple DNS for discovery and letting the platform figure out the scaling necessary to figure that out, and so you really aren't exposed to that as an application user. And B, the thing where I think that we are going to see more of this in the serverless world is around observability and monitoring. I think that my feeling is that the serverless vendors are going to take ideas from service meshes and start embedding those within serverless tools. And I'm a little bit biased, but I think what we're going to see more and more is that containers and container platforms are going to be ways that services are provided to us as application developers, and actually as application developers we're going to be using the containers in a raw way less and less over time, at least container orchestration.
Right, thank you. And actually this was our first not anonymous question today, so thank you, Jean-Marie, for asking us.
Thank you.
And the second question is going to be this one. What to do if your customers don't really want to experiment, which is something almost all of us encounter at least some point.
Yeah, and this is about, you know, I'm not a product manager, right? So I'm not going to pretend that I can offer an amazing answer to this. But you know, typically when you have customers, you have cohorts, right? You have your, I just want the thing to work and don't give it to me unless it works. And then you have your early adopters, right? And you figure out who your early adopters are, and they may be a little more risk happy. And if you can, what you want to do is try and segment your customers into ones that are willing to experiment and try and find those. That's sort of what a lot of companies do is figure out a way of doing that. Alternatively, you may do things like A/B testing, and your customers might not even know that they are being experimented on, which is always nice.
Good idea.
Yeah. Or alternatively, sometimes that's sometimes where I mean, I didn't say get rid of our product managers. I said take the role of product management and spread it across. People that have been product managers are going to have a mindset that engineers don't have. Just like we haven't got rid of sysadmins, we've embraced sysadmins on our teams. The stuff that sysadmins can do is extraordinary. I mean, Dan North talked about this earlier. You know, go and hug your sysadmins. Just because they're not on their own separate team necessarily anymore, or we're as application developers aren't on our separate team. Doesn't mean that there isn't a lot to be gained by having them on your team. So I think product managers are going to be very are going to be able to answer this question, figure out, oh, can we simulate, can we come up with some ideas, can we segment, whatever. So that's where I lean on product managers.
Perfect, thank you. We still have time for one more question, if I'm able to read it in time. While TDD is not going to be more widespread to protect the product against introduced bugs, why would we want to deliver many times a day without proper testing and to risk the production system's stability?
Ooh.
Wow, that's a hard one.
So this is more a question of the sort of continuous delivery tries to get to the heart of, rather than necessarily what we're talking about experimentation here. So continuous delivery says a couple of things. First of all, actively let's try and have as many automated tests as we can in a system. But what you also get with continuous delivery, and one of the things they talk about and accelerate, is how quickly you can roll back a problem release. So the idea is that if you can roll back a release extremely quickly, then if you get some bugs in production, that might not be a terrible thing. And in fact, some people are actually embracing the idea of testing in production. And especially if you can release some code and then just drive a proportion of traffic that may be very controlled traffic to that system and figure out whether there's bugs using production load, then that may never even hit the customers in the first place. So it's not about ignoring the risk that comes from releasing buggy code, but it's about how do you manage that risk and how do you actively decide what to do with it.
Thank you, Mike. As Mike said previously, he's going to be staying around for your questions to answer, but our time for the Q&A is up. So we have a 10-minute break, and before that, I would like to thank Mike again for this amazing talk. Everyone, give it up for Mike.
Thank you. Thank you, everybody.